Modern batteries are built to very high standards, as we have learnt in previous chapters. There is also some very important things to do when we're handling the batteries. So in this module, we'll cover safe handling, maintenance and storage of batteries. So although these are very important, we'll also be covering terms like state of health and state of charge. So let's go and find out what these all mean. State of charge, or SOC, is something that we have all heard of. If you have a mobile phone, in the top corner you have a little battery indicator. Although we might say that my battery is running down, it's actually the state of charge that is running down on the battery. But unfortunately, on an automotive battery, we don't have such an indicator. To determine the state of charge of an automotive battery, you have to do two things. First, measure the battery voltage. For highest accuracy, it's always recommended to measure directly from the battery terminals in order to avoid any bias through the wiring. Sometimes the battery is very difficult to access, for example when it's located under the driver's seat. In these cases, you might like to measure somewhere else to get a first indication. In these cases, the jump start connections are a good alternative to connect the measuring device to. No matter where you measure, at the terminals or somewhere else, make sure that the surface of the connection is clean blank metal. You can use a simple voltmeter or a digital multimeter to determine the voltage. If you're using a digital voltmeter, make sure you have set it upright to DC, direct current, and select the right voltage range. Once you have the voltage, you need to translate this voltage into state of charge. For flooded batteries, the voltage of a fully charged battery, so 100% SOC, is approximately 12.8 volts. For AGM batteries, the voltage is slightly higher, 12.9 volts for automotive AGM and 13 volts for truck AGM. The voltage of a fully discharged battery varies according to the technology, size and design of the actual battery you are measuring. But in general, a voltage below 11.5 volts for automotive or below 11.8 for truck is critically low, around 0% state of charge. A voltage of 12.2 volts for automotive or 12.3 volts for truck batteries is the approximate value representing 50% state of charge. With those three values, you can already determine the state of charge of a battery pretty well. If you measure the voltage, you need to make sure that there are no electrical loads draining current out of the battery, because this will give you a lower value. Also, be aware that measuring the voltage directly after charging, you will measure a voltage that is higher than the actual state of charge. Please keep in mind that after charging also refers to a car that has just arrived at the garage, because in this case the battery has been charged by the alternator while driving. Because of this, the values given before, 12.8, 12.2 or 11.8 volts, are so-called open circuit voltages, or OCV, which means no charge or load on the battery. The second important term is state of health. A battery on a vehicle can wear out. Just as we check the brakes and the tyres, a battery should be tested too, so we don't wait until the tyre explodes or the brakes on a vehicle are metal to metal. It's important that we test the battery and we replace the battery before it will not start the car. To determine the state of health of a battery, a special battery tester is needed that can analyse different internal variables of the battery. Factors that may influence the state of health potentially are grid corrosion, sulfation of the plates and wear and tear of the active mass of the plates. Usually, a battery tester doesn't give you just a numeric value of the state of health, but a more specific result like good battery or replace. If the battery already is in a state between good and replace, you might also get the result charge and retest. This could already be an indication that the battery will come to its end of its life, and you might inform the customer about the risk of a potential breakdown and recommend a preventive battery change at the next winter season. The state of health becomes even more important for vehicles with start-stop functions and/or sophisticated electrical functions, since the battery has more integrated role within the vehicle's electrical system. In order to get reliable results, it's crucial to use a battery tester that is able to differentiate between AGM, EFB and SLI batteries. As we talked about the different battery standards in Module 2, it's also very important to select the right battery standard, EN, DIN, SAE or JIS when testing. The capabilities of battery testers are limited, as there are so many different batteries from different manufacturers with different designs and levels of quality in the market. The algorithm of the tester can't be 100% accurate. On the other hand, the manufacturers of battery testers continually develop and improve the algorithms and devices. Therefore, it is recommended to use a tester with the latest technology in order to get the best and most reliable results. So let's summarise the most important topics. We can measure the open circuit voltage to give us an indication of state of charge. And also, to get good results, it's important that there's nothing draining the battery or charging the battery. And also it's important that the battery doesn't have any surface charge. This means that the battery hasn't been on charge or it hasn't just arrived in the workshop from a vehicle and been charged by the alternator. As the books say, we should give a battery a bit of time after it has been on charge. So if a battery has been on with a bench charger, we should let it rest for about 4 hours for the charge to equalise. And if a vehicle has just came in and it has been charged off the alternator, we can switch the lights on to take the surface charge off before we measure the open circuit voltage. When determining the state of health of a battery, it's important that we use a special battery tester. This tester should be as new as possible so that the algorithm is as up to date as possible, because new technologies are constantly coming out. It's also important that the battery tester can select between SLI, EFB and AGM batteries. Another important consideration for the battery tester is that we can select the different standards. So we can select DIN, EN or JIS as required. It's important that your battery tester has a printer as well. And one thing that you can do is, once you print the results off, make sure that they match the standard that is on a battery. Battery testers are designed to test used and cycled batteries. Therefore, they should not be used to test new batteries. For example, batteries coming into stock. Always connect the battery tester directly to the battery terminals and do not use any other connection or the jump start connections. Why is it important to connect to the terminals of the battery? Well, your battery tester comes with leads of a certain length, and these leads will be calibrated to your tester. If we then test the battery off jump start points, there is a chance that we'll get an inaccurate reading. I would also like to point out that the voltage of a battery, so the state of charge, has nothing to do with the state of health of a battery. So, with what you know about state of charge and state of health of a battery, you're very close to becoming an expert and be able to hold good conversations with customers or your colleagues. However, there's 2 more things that I would like us to discuss first. The first one we need to talk about is the internal resistance, and basically this term already describes very well what it is about. The internal electrical resistance has an important influence on the cold cranking performance and also the charge acceptance of a battery. The resistance increases with age and the degree of use of the battery. To give you a flavour of the value we're talking about, the normal internal resistance for an automotive or truck battery is less than 3.5 milliohms for a new battery. When measuring the internal resistance, do not use a conventional multimeter. This won't work. You will need a special RI measuring device for batteries. Do you remember what happened to the electrolyte when we looked at it in Module 3? As the electrolyte takes part in the chemical process, the concentration of sulfur decreases during the discharge process. Therefore, there is a direct correlation between the acid density of the electrolyte and the state of charge. In the past, it was quite common to measure acid density while servicing a battery. Nowadays, most batteries are fully sealed, so you are not even able to measure. Therefore, it is absolutely sufficient for this training that you have just heard about this parameter. Okay, let's wrap up the key takeaways from internal resistance and acid density. We learnt that internal resistance has a direct relationship to charge acceptance and also the power that a battery can put out. We learnt that the older a battery gets, the higher resistance gets, and we also learnt that the lower the resistance is, the better. We also learnt with acid density that there is a correlation between battery voltage and acid density.